Android has officially instituted a strict Compose First mandate. Legacy view systems, XML layouts, and fragments are now in maintenance mode, receiving only critical bug fixes. All new platform APIs, libraries, and guidance expect your application to be built on a modular, declarative UI framework. But this UI shift arrives alongside a severe structural tightening at the runtime level. Android 17 enforces strict memory boundaries across the entire ecosystem. Applications that leak memory or exhibit runaway resource usage will no longer degrade the user experience. Instead, the OS will protect the Android runtime by terminating those apps entirely. While execution limits are closing in, functionality demands are expanding. Android now treats your application as a collection of background tools for agents like Gemini, shifting away from the model of the app as a simple UI container. To maintain stability in this environment, we have to rebuild the modern Android application stack layer by layer. We will map out the transition to Adaptive Compose, trace the restricted runtime constraints, and implement the new integration layer for system agents. Updating to Android 17 is an architectural mandate to build modular, memory-disciplined, and system-integrated software. At the presentation layer, the deprecation of legacy view components means your legacy code is now technical debt. Compose 1.11 introduces the Experimental Styles API, which separates component logic from visual design. Component definitions split into two explicit layers, one managing state and behavior, and a standardized set of attributes governing the appearance. By decoupling these concepts, frequent UI state changes can be processed without forcing the appearance layer to redraw, automatically minimizing recompositions and saving CPU cycles out of the box. Compose 1.11 also introduces necessary adaptive primitives, specifically Media Query, Flexbox, and Grid. Android 17 now ignores fixed orientation attributes entirely. These primitives enforce dynamic resizing across foldables and large screens, ensuring your interface scales whether the user expands a fold or docks their device. To route users through adaptive layouts, the Navigation 3 library provides scene decorators in version 1.1. This allows you to manage global UI elements, like navigation rails, at the scene level rather than the individual nav entry level. And with Navigation version 1.2 Alpha, robust deep link support ensures agents and system intents can drop users directly into those distinct scenes. If you are still maintaining legacy XML, Android Studio now includes AI tools that analyze your project-specific styles and resources for deterministic XML to Compose conversion, backed by automated screenshot testing to verify the results. For developers pushing UI outside the main app, Jetpack Glance replaces legacy tiles for building adaptive widgets targeting cars and foldables. The shift to Compose provides the lightweight, highly adaptive front-end necessary to operate within Android 17's strict resource constraints. Beneath that UI layer, Android 17 asserts its execution constraints. Runaway resource consumption triggers immediate, silent system intervention. The OS communicates these terminations directly back to you via the Application Exit Info API. If your session exceeds its bounds, the exit reason string will clearly output memory limiter. To further enforce this discipline, Android 17 bans the modification of static final fields via reflection. Locking this down enables the Android runtime to apply deep performance optimizations that were previously blocked by unpredictable memory states. You also benefit from a new lock-free implementation of the Android message queue, which reduces UI jank during high-contention scenarios without requiring you to rewrite your threading logic. Your primary defense against bloated memory footprints is the R8 Configuration Analyzer. It scans your compilation step to identify overly broad keep rules that thwart optimization, stripping out unused code and shrinking your resources. This chart shows the direct result of auditing those rules. Tinder removed a single problematic keep rule identified by the analyzer, resulting in a 28% drop in APK size and a measurable decrease in application not responding rates.
To catch memory issues early, the Profiling Manager API now includes automated triggers for out-of-memory, cold start, and excessive CPU events, allowing you to pull specific heap dumps exactly when an anomaly occurs. The Android Studio Profiler also now features native leak canary integration, augmented by Gemini to analyze the dump and diagnose the source of the memory leak. And for system-wide trace loading, the new Android Performance Analyzer replaces the legacy GPU inspector, rendering those traces up to 26 times faster. Mastering this specific runtime tooling stack prevents your application from being silently purged by Android 17's aggressive memory management. Android 17 also restricts broad data access, requiring developers to adopt privacy-preserving pickers instead of relying on wide net permissions. Rather than requesting blanket permissions, you now extract specific data points directly. The new Eyedropper API pulls a single pixel's color data without full-screen capture privileges. Similarly, the Contacts Picker restricts access down to a single designated field for a specific contact, keeping the rest of the list secure and inaccessible to your app. If you build for Google Cast, the output switcher replaces the need for the Access Local Network permission when discovering and connecting to hardware. At the binary level, a new security mandate requires any dynamically loaded native libraries to be strictly read-only, preventing post-compilation tampering. You can also bypass the friction of SMS one-time passwords. Credential Manager now generates legacy passkeys for existing users and executes verified email and phone number checks directly through the provider. For hardware rendering, Vulkan is now established as the definitive native GPU API. For managed code environments like Art and the web, you can access GPU performance through a new idiomatic Kotlin API for web GPU. Shifting to targeted pickers and secure memory execution protects user data, while reducing the security liability footprint you have to maintain. Today, Android is rapidly transitioning to an orchestration model where your apps serve as background toolsets for system-level assistance. Android implements the Model Context Protocol, or MCP, allowing your application to operate as an on-device server for client agents like Gemini. By annotating a suspend function with @function, you expose discrete capabilities directly to the OS. Gemini can parse the JSON, pass parameters, and execute the function in the background, bypassing the UI entirely. Implementing this requires strict architectural separation. Your presentation layer and your data layer must be fully distinct. Otherwise, the agent cannot access the function without launching a screen. Android Studio now includes skills that will auto-generate these functions based on your data models, automatically producing the KDoc metadata that tells the AI exactly what the tool does and what parameters it requires. You can also execute AI tasks locally via the MLKit prompt API. Running Gemini Nano 4 on device carries distinct operational advantages. It incurs 0 per transaction server costs, keeps sensitive user data entirely local, and functions seamlessly in airplane mode. For high-end tasks, new vendor-defined extensions allow developers to execute complex media processes, like image upscaling and tone mapping, directly against on-device hardware. By integrating app functions and on-device models, your app transitions from a standalone silo into an interconnected tool utilized by the entire Android ecosystem. Looking at this entire architecture stack, the blueprint for modern development is clear. This graph charts the balance Android 17 requires. Google enforces strict runtime constraints and memory boundaries on one axis, while offering expanded OS-level capabilities and AI integration on the other. Your immediate checklist is straightforward. Migrate your front-end to Compose, audit your keep rules with the R8 Analyzer, adopt privacy pickers, and build clean backend endpoints for app functions. Apps that embrace lightweight, agentic, compose-driven architectures gain full access to the new capabilities of the OS, while legacy systems risk runtime termination and isolation.